In this lesson, we're going to be talking about our third and final type of transformation, which involves slope change. The technical term that we have here is called horizontal and vertical stretches and compressions. By the end of this lesson, you should be able to graph a new line given its new slope. You should be able to write the equation of a new line, and you should be able to describe the type of transformation that is occurring. When we talk about slope change, this is when the graph of a line is being stretched or compressed. It's either being stretched away from an axis or it's being compressed towards an axis. And the two axes that we're looking at are the x-axis and the y-axis. When we are writing out the rules for horizontal and vertical stretches and compressions, we have 4 rules that we're going to be writing out. So we're going to have 2 for horizontal compressions, and the rule for horizontal compressions is going to be f of bx. B represents a number, so f of a number times x. You're going to have some number inside the parentheses that's being multiplied to x. If that number is greater than 1, then what we see is that it's being compressed horizontally, so it's being pushed horizontally in towards the y-axis. So it's like taking an accordion and pushing the accordion in until you meet that vertical axis, that y-axis. And if the number is between 0 and 1, this means that if it's a fraction, a proper fraction, between 0 and 1, then it's being stretched, it's being pulled away from the y-axis. So it's like taking that same accordion, and instead of pressing it in this time, now you're stretching it out. So for example, if we have f of 4x, notice the number is inside. What you're going to see is you're going to see a line that is 4 times steeper than it was before. So it's going to be, if it's 4 times steeper, what that means is that it's being moved, it's being compressed closer to the y-axis. The other thing that you're going to notice is that if it's just a horizontal compression or just a horizontal stretch, what you'll notice is that the only transformation that's occurring, the only thing that's going to change is the steepness of the line. The intercept is not going to change. That y-intercept is not going to change. When we talk about a vertical stretch or compression, what you'll notice here is that the number is now on the outside. So we have a times f of x. We have some number being multiplied to the outside of f of x. And what this is telling us is that if a is greater than 1, now it's being stretched vertically. So it's being pulled away, okay, vertically this time. So not horizontally, but vertically, away from the x-axis. And if that number is between 0 and 1, now it's being compressed. So again, if we have a number between 0 and 1, that's our fraction, then it's being compressed towards the x-axis. So that would be like pressing a soda can from the top and the bottom, pushing that in. That would be vertical. Or if you're uncompressing, if you're stretching that back out, that same soda can out, that would be that vertical stretch or compression. So if it's greater than 1, then it's being stretched away from the x-axis. If it's between 0 and 1, then it's being pressed towards the x-axis. So if we have 2 times f of x, then what you'll notice is that this line is going to be 2 times steeper than it was before. So this would be a stretch away from the x-axis. What you will notice here is that the intercept may change or may move. All right? So the intercept is going to change when we're doing vertical stretches and compressions. Okay, so let's look at a couple examples. So if we're looking at number 1, we have our parent graph, f of x equals x. Remember, that's our line that starts at the origin, has a slope of 1. And if we're doing a stretch or a compression here, okay, so let's look at this first one. The number is on the outside. So when the number is on the outside, remember that this is a vertical. Okay, so we're either vertically stretching it away from the y-axis, that's a number that's greater than 1, or we are vertically compressing it towards the x-axis, that's our number that is less, or that's between 0 and 1. So let's look at this first one. So we have f of 2x. So what we're doing here, and this is really important for us, what we're doing here is we're taking all of f of x, so in this case f of x is x, and we're multiplying it by 2. And so what we end up with is 2 times x, or 2x. So this is our equation that we're going to graph. So we're starting at the origin, and instead of my slope being 1, now my slope is 2. And so what you'll see is that it's moving, the steepness of our line, the direction of our line is moving further from the x. So notice that my distance between my points is further from the x-axis. So it was being stretched away from the x-axis. If we're looking at g of x equals 1/2 times f of x, this would be a compression. So what we'll see here is that it's going to actually get closer to the x. But what we have here is it says take f of x. So what it says here is it says take f of x and multiply f of x by 1/2. So in our case, f of x is x. So we're taking 1/2 and we're multiplying it to our function of x, which in this case is x. So we're starting at the origin, just like we did with our other two graphs. The y-intercepts didn't change on these. And I'm taking my slope now, which is not x, is not 1, but is now 1/2. So what I would do is I would go up 1 over 2, up 1 over 2, down 1, back 2, down 1, back 2. And if you notice, my blue line, which was my vertical compression, got closer. Okay, those points got closer to the x-axis. Now, if we're looking at horizontal stretches and compressions, this is either compressing it towards the y or stretching it away from the y. So now our focus is on the y-axis, not the x. And what we're going to do is we're going to take our parent function, that's f of x equals x. So it goes through the origin. That's slope of 1. Okay, so we're taking f of x. Remember, anytime it's on the inside, the number's on the inside, what this tells us to do is it says evaluate f of x for 1/2 x. So if f of x was x, f of 1/2 x would be 1/2 x. Anywhere where there's an x, we would replace it with 1/2 x. So instead of x here, now we have 1/2 x. And so what I'm doing on this one is I'm going to graph it. So we're graphing 1/2 x. Okay, so we start at the origin, have my slope of 1/2, so up 1 over 2, down 1, back 2. And what we'll notice is, again, our focus is on the y-axis. So if the number was less than 1, so between 0 and 1, remember that this was a horizontal stretch. So what we're saying is that our line is moving away, is moving further away from the y-axis. So if you notice, our parent graph was closer to the y-axis than our new graph. If we look at g of x equals f of 2x, this would not be a horizontal stretch, but this would now be a horizontal compression. And so let's look at what this graph would look like. So just like before, when we see the number on the inside, this tells us to evaluate or replace x with whatever's inside. So instead of x here, we would have 2x. So what g of x would be equal to is 2x. So anywhere where there was an x in that equation, now we have a 2x. Again, we're starting at the origin when we graph it. We're using our slope, which was 2. And we're getting the graph for a line. And so what you'll see is that now our blue line is actually closer to the y-axis. It was stretched toward, or compressed towards the y-axis. So it's actually closer than our previous line. The biggest thing here is that even though the two lines look the same from that parent graph, from example 1 to example 2, it's really the focus on the axis? Are we focusing on the x-axis or are we focused on the y-axis? Okay, we're going to determine the transformations that are happening here. All right, there are multiple transformations that could be taking place at the same time. So if we're looking at A, we have f of 1/4 x. The 1/4 is on the inside. And so what this tells me is that it's horizontal. Because it's 1/4, that tells me that it's a horizontal stretch. So we have a horizontal stretch. And we have this +2 on the outside. If you recall from 2 videos ago, that adding or subtracting on the outside or on the inside was a translation. So what we have here is a horizontal stretch and moved up 2. So we have 2 transformations that are happening here. If we look at B, we notice the numbers on the outside. So this would be vertical. Because it's a fraction, we know that it's a vertical compression. So we have a vertical compression and it moved up 3. If we look at C, again, that number's on the outside, so it's still vertical. So we have this time a vertical stretch because it's a number that's greater than 1. And we have +3 on the inside. Remember that this moves it to the left 3. And then if we're looking at the last one, we see that it's f of 4 times x plus 2. So 2 things are happening here. First, we have a horizontal compression because we have a 4 on the inside that's being multiplied, and it's greater than 1. So this would be horizontal. So horizontal compression. And it's also moving to the left 2 because we have +2 on the inside. So horizontal compression and moved left 2. If we look at 4, it says, given f of 1/3 x minus 1, graph the original line and the indicated transformations. So we're graphing the line, so 1/3 x minus 1. Right. There's my line. And we're performing the following transformation. So you really have to know how to use the equations here. So anytime it's on the inside, remember that that is horizontal. And if it's on the inside, what it tells us to do is it says evaluate your function. So evaluate 1/3 x minus 1 for x being 3x. So instead of 1/3 x minus 1, what we'll have instead is 1/3 times 3x minus 1. And then simplify. 1/3 times 3x is just x, and then minus 1. The minus 1 didn't change. So what this says is that we have the same y-intercept of -1, but now instead of going up 1 and over 3, we're just going to go up 1 and over 1, because the slope is now 1. So here is my translated line of g of x. If we look at h of x, again, we're taking our equation, which was 1/3 x minus 1, and we're evaluating it this time for 1/2 x. Again, this is going to be a horizontal stretch, so what we should see is that our graph moves away from the y-axis. So we do 1/3 times 1/2, which is 1/6 x, minus 1. Again, the minus 1 is not affected. So we start at minus 1. This time we're going up 1 and over 6. So I've got to go off my graph a little bit, down 1 and left 6. Got to go off my graph a little bit, and we should have a line that is further away, okay, that is moving further away from the x-axis, or the y-axis. Okay. If we're looking at 5, again, given the graph, given the indicated graph, so we have 1/3 x plus 1, so given that, there we go, there's my graph. It wants us to do the vertical stretches and compressions. So it wants us to do the vertical slope change. So in this first one, we have 3 times f of x. This is a vertical stretch, so we're moving away from the or the x-axis. We should notice our graph moving further from the x-axis. And what we're going to do here is we're going to multiply the whole function, 1/3 x plus 1, by 3. So if it says 3 times f of x, it says take all of f of x, which is 1/3 x plus 1, and multiply it by 3. And so what we'll see here is when we do 1/3 x, when we do 3 times 1/3 x, that's just x. When we do 3 times 1, that's 3. And so g of x is equal to x plus 3. So notice that the y-intercept changed and the slope also changed. So both things changed here. So what we should have noticed is that it got further away from the x-axis, and it did. For 1/2 times f of x, again, that's the same thing as what we were just doing, except now we should notice that this is a compression, so it should be pushed closer towards the x-axis. And what this wants us to do is it wants us to take all of f of x, so it wants us to take that 1/3 x plus 1 and multiply by 1/2. So what you'll notice is we'll have 1/6 x plus 1/2. So my y-intercept is now 1/2. My slope is 1/6. So it says go up 1 over 6. I've got to go off a little bit. Down 1, back 6. And again, what we should notice is that it's being compressed towards the x-axis, and in this case it is. Okay, before watching the next video, what I would like for you to consider is how we know the difference between horizontal and vertical slope change. As usual, please subscribe to the channel so that you get updates as new videos are released. And thank you for watching.